In the previous lesson, we learnt about FreeCAD's thickness tool. That is a tool in the part design that allows you to thicken the walls of an object, creating a hollow inside. In this lesson, we'll tackle a practical project. We'll create an electronics enclosure that incorporates a plug fitting. And here's the actual product from the real world. Before we begin this project, let's analyze a few workflows. If you've been following along with the previous videos, you'll understand that we begin with a simplification process. The part design workflow in FreeCAD requires us to create initial features and then extend those by adding subsequent features on top of the previous one. Simplification, however, works in reverse, removing features to identify the core form to determine the necessary operations. In this case, we eliminate the finger well, the top pockets, and in some instances, even the internal hollow. This allows us to visualize the fundamental shape, which looks something like this. One approach is to tackle the subject by working from the bottom up. We can see that the features are constructed in layers, with each layer helping us to identify the necessary operations. We can see that the first layer can be represented by a loft. It has consistent shape profiles that vary only in size. Top part can be formed by a simple pad, but the challenge arises when blending it with the previous mentioned loft. The loft appears to extend, partially enveloping the pad. This can be achieved by creating the profile for the plug and applying the pad in both directions. Recalling our lessons on lofting and remembering how B-spline interpolation defines the loft shape via using multiple profiles, it may be beneficial to simplify the design by minimizing the number of profiles needed. Instead, we can extend the top face to accommodate the curvature change as it transitions into the plug housing. This results in a shallower curvature where the loft and plug housing meet. Key advantage of this approach is that it creates a planar face when we pad the profile formed by the top face of the loft. This is because it consists of straight edges, which in the future allows sketches to be attached to the resulting face for additional features and detailing, such as ventilation holes. With a non-planar face, we would have to use advanced attachment modes. But we're making the model increasingly more complex to hollow out. So let's take a step back in our process, focusing solely on the loft and the tapered pad. Once again, we see a potential failure point where the loft meets the pad. All the adjoining edges are near tangent, which, as covered in the previous video, can present a challenge. To address this, we may need to make some minor adjustments to the taper to ensure the thickness is applied correctly. Once the thickness is successful, it's worth adding the finger well. This can be done using a simple sketch and a pocket. Then we can apply the thickness operation. Again, we must be cautious not to encroach on an edge that is already close to failure due to that near tangency. As always, there's multiple approaches. An alternative workflow is to approach the subject from the side, creating the initial shape with the additive pipe operation. This eliminates the need for applying the thickness altogether. The sketch that we used for the loft in the previous workflow, we can use that as a path. We just need a cross-section sketch to define the profile to sweep around it. This allows us to create the shape with a single additive pipe. Then we can tackle the finger well. Again, this is removed with a pocket. But we have an additional challenge. We have to recreate that finger well. A half tube profile can be used to do this. A simple sketch of that profile is created, followed by a pad. But we need to remove the excess material so it blends in with our additive pipe. This can be done by creating a sketch that uses the edge profile of the existing shape, allowing us to define a profile that we can use in a subtractive operation. Using the profile and creating a subtractive pipe, we can remove the unneeded volume. We've covered two ways of creating this hollowed out feature, but the workflow doesn't stop there. We've got an open top now. So we would have to close that with a pad before following the process to blend the plug into the model. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content. And that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. So we've started in FreeCAD, we're in the part design. and I've created a new document. Let's start by creating a body, and we'll create a sketch for the first cross section of our loft on the XY plane. I'm going to use a standard rectangle and place this across the center point. Right click to cancel the tool. We'll center the rectangle by taking the opposite points at the corners and then the center point, and then use the symmetry constraint. Let's set some height. For this line here, we'll set to 60 millimeters. Right click to cancel the tool and just pull this down here. I'm going to fillet off these edges to make our shape. Using the fillet tool, create a fillet. Click once on the top edge and then click on the left edge. You notice it's maintained the constraint because it's created a point here. Do the same on the other side. You can see the constraint is still maintained. Do the other edges. Right click to cancel the tool and then add another constraint using the dimensioning tool. Let's set the width. This point, bring this down, and again this one will be 60 millimeters. While we've still got the dimensioning tool active, let's take this arc, bring this out, and set this one 20 millimeters. Right click to cancel the tool and you can see that the arc is constrained. I'm going to take this arc and select all the others and use an equal constraint. That fully constrains the sketch, which we can close, and we have our first cross section. Let's come over to the draft workbench. I'm going to use the drafting tools in the draft workbench to clone this cross section. To do that, we select the sketch, then we use the clone tool, or modifications, and clone. Select the sketch again, and we'll create another clone, and one more. We've got 3 clones of that sketch. With the clones, we're going to change the placement and the scaling. So the first one, come down to the data tab, look at the placement, open that up, and look at the position. We'll place this 2 millimeters along the Z-axis, and the scale we keep the same. The next one, come down to the placement. We'll set this one to 12 millimeters. Scale, let's open that up, scroll down, and we'll set all of these to 0.8. I'm just using the tab on the keyboard to navigate through the fields and hit enter. Our last clone, take that, come down to the placement, position along the Z-axis of 10 millimeter. Down to the scale, and we'll change this 0.9. Using tab again, navigate through the fields. We'll hit enter. So we have our cross sections. When we loft through here, we get a loft, which we can alter with the scale or by editing our first sketch. If we edit the first sketch, all the clones will be updated with the new geometry or the new dimensions. Let's come back to the part design. Onto the model. We notice if we look at the body, if I collapse that, all the clones of the sketches are outside. These need to be inside. So let's take the first one, and then we can hold down Shift on the keyboard and select them all and drag them into the body, or we can drag them in one by one. Let's open this up. We have our first sketch, and we can see that the profiles, as we move down through them, we can see what order they are in. Now, there's 2 ways of adding the additive loft. We can select the profile first, our first profile, then use the additive loft and add the second, third, and fourth one in, or we can select them in order. We've got our first sketch. If I hover over the second one, you can see it's turning yellow in the 3D view. Let's control select that one. Our next one, well, this isn't the right one, that's the top one. So let's go to the bottom one, control select that one. And then the next one, select that. And then we can add the additive loft. Let's create the loft for all of those. Let's hit OK. We're next going to create the part that's going to merge between the additive loft and the plug. We select the top face. We're going to pad this face. We don't need a sketch. We just use the face and click the pad. Look to the left. We can see the length at the moment is 10 millimeters. Set this to 3. Then we come down to the taper. If we decrease the taper, I'm using the mouse wheel. We see it go inwards. I'm going to set this to -60 and click off. We have the taper there. Because we've created a straight line here, as it curves up here, this won't be a planar face, but this one will be because we just created a pad from here and tapered this inwards. This means this face can be easily connected to without using the advanced attachment modes. We'll be using these faces later. Let's hit OK. Now it's time to create the finger well. Let's bring this around so we can see the bottom of the shape. Let's select the bottom view. And we can flip this round if we wanted to, doesn't matter. Select the top face and create a sketch upon it. We'll import this edge here using the Create External Geometry tool, and then come down and hover over this edge. You can see it highlighted there. Let's click that, and now we can attach a sketch to this. We can just about see the dotted line in there. Let's right click to cancel the tool, go to the model, click on the pad and press the spacebar. We can see that dotted line in there much clearly now. Click on the pad, press the spacebar, we can see it there. Use the circle and connect up to the vertical axis and bring out a circle. Right click to cancel the tool and take the center point and the imported edge. Select both of those and use the coincident constraint. That places it upon that edge. We can add some dimensions by selecting the circle and using the dimensioning tool. Adding a diameter of 10 millimeters. Come over to the tasks and hit close. We've got the sketch. It's connected to this face. So select the sketch and hit the pocket. Starting to pocket through there. The length at the moment is 5 millimeters. Let's go through all. So I've created the finger well. Notice that it doesn't intersect this edge. Let's hit OK. Let's come in and select the top face and then use the thickness. Also available from part design, apply a dress up feature and use thickness. Thickness has been applied. You can see how close we are to failure with this edge here. So if this edge gets any smaller and starts to intersect this one, then it will fail. At the moment, the thickness is 1 millimeter. If I increase this, we can see it's taking, and then it goes into error at 1.5 mil. Adjusting the taper will make this succeed. Just going to change this to 1 millimeter and click off so it takes, but we also have to be wary of where this is intersecting. As we increase this, you can see we're encroaching on that edge. And as it goes into that edge, it fails. So it's back to 1. Let's hit OK. Now the thickness has been applied. Let's come around to the top face and create the sketch for the plug. Select the top face and create a new sketch. Let's create the plug sketch in here. For this, I'm going to use some lines. Placing the lines within. Then I'm going to connect these lines with Create Art by 3 points. Hovering over the point to get coincident constraints and point of the line, and just add in some arcs in here. Working our way around. Right click to cancel. I'm going to move this line up and this line down because I'm going to pull in this line here and create a constraint against them. Let's use the external geometry tool, create external geometry, and pull in this line and this one. Right click to cancel, use the dimensioning tool and set some dimensions between this point and this one here. Set some height of 2 millimeters and repeat for the top. Set that to 2. Let's use the tangency now and create tangency between the arcs and the lines. Now we'll get this message coming up. Now it's up to you if you want to uncheck the checkbox so it stops it from coming up. I'm leaving it there so it's seen in future videos. Once we've got all the tangency in place, we can start further constraining this model. Hit OK. Right click to cancel the tool, and we import the geometry of this arc and this one. Right click to cancel. And again, I'm going to use the tangency between this arc and this one, and the same on the other side. Right click to cancel. We have that one there. And take this point and this one, this vertical axis, and use symmetry against those. Take these two arcs here, make those equal, and take these 2 points, vertical axis again, and use symmetry. Now it's totally up to you how we want to constrain this. There are multiple ways. I'm just going to bring this out, and I'm going to take this point and the horizontal axis, use coincident, which is point on object constraint. That's on there. I don't need one from the other side. Taken care by this one. And now I can set some radius. This is the shape I want. It's totally up to you how we want this. So this arc here, let's set the radius of that. Set it to 16. I've got 1 degree of freedom left. Right click to cancel. I'm going to set the radius of this arc using the dimensioning tool and set that to 17 and hit enter. The sketch is fully constrained. Let's close out of there. We can see how that's sitting on the object. So we've pad this now by selecting the sketch and using the pad. It's going to be overhanging in here. So let's set the length to 3 first, and then change the type to 2 dimension. What that does is pushes another dimension down, so it's padding up and downwards. And you can see that we're starting to merge into this face. Let's set this to 3 because what will happen is it's going to punch through and out the other side. Let's set that to 3 and click off. Just come in and make sure we haven't got any overhangs, which we haven't. And let's hit OK. So we've got the plug sketched and the pad added. Next we can start with the detailing. So we can add the holes to this surface here by clicking on it and pressing Create Sketch. Now with this one, I'm not 100% sure because I haven't got the plug here of the dimensions. It's also totally up to you if you want to use a UK layout, a US layout, a European layout, totally up to you. So for this, I'm just going to place a circle connected to the center point, bring this out and right click to cancel. We'll change this to construction geometry by selecting on it, then coming up to the toggle construction mode. Also available from the right click and toggle construction geometry. That's become dotted now, so it won't show up outside the sketch, but we can constrain to this. Let's use the rectangle, place a rectangle at the top and the sides. Place this one, say around about here. Right click to cancel. Let's move this one down. And I'm going to place a point in here. Connect the point up to the construction geometry, placing that point on object constraint. And we'll right click to cancel and take these 2 points and place them in line with each other. Next, let's place some dimensions between the 2 points and set that to 24 millimeters. So what I'm doing is building construction to allow me to attach these two. And I'm looking to adjust this so we can easily adjust the geometry that's connected to it. Let's bring this down and place these 2 points, this point and this one, and the center point. Make that symmetrical and do the same with this one as well. These two and this one, and use the symmetry. Let's add some dimensions now using the dimensioning tool. Take this top line, 3.5 millimeters, and the side, we'll set that to 8 millimeters. Right click to cancel, then we can take the top line and the side lines of these, make those equal. And let's do the same for this line here and these top lines, making sure we select them first. And make those equal. So at the moment, these can move up and down, as you can see. 24 millimeters apart, and we need a point in here as well, because I haven't centered this yet. So let's take the point, connect that to the arc. You can right click to cancel and take the point and connect it up to the vertical axis with a coincident constraint. Add a point on line constraint there. And then I can take these 2 points and center it with this point using constraint symmetric. So these can move now, so I can set the diameter of this when I'm happy. Let's set the diameter of this. Now it has no degrees of freedom. We'll set that to 28. We're fully constrained now, and I can hit close. The points are showing. Those should be construction geometry. Now we may be able to pocket this. It's allowing the pocket, and we go through all. Let's hit OK. If this didn't allow the pocket, then we would have to change the sketch and set these points to construction mode by just selecting them using the construction. We're toggling the construction mode there. Select that point again. Let's highlight that. The filters over here at the moment, I'm filtering it by construction. Let's use normal. So we've got them all. So we can see all of them there. Let's hit close. Those points now, if I select the sketch, press the spacebar, you can see the points have disappeared. Select that sketch, press the spacebar again. So we've got our plug holes now. We've got one final piece of geometry to add, and that's the ventilation holes. Now we can see that this is a planar face. So we can just select it and sketch upon it. We're upon that face now, so you can see it there. Let's just use View Sketch to view that from the top. Let's learn a new tool, and that's this tool here, the Move/Array Transformation. This allows us to create some geometry and array that across here. I want 4 rectangles. So first, let's bring in a rectangle and place it here. Right click to cancel. Take this edge, place some dimensions, and set that to 3 millimeters and hit OK. At the top length, 2.5. So we have our rectangle. If this is going to repeat, then it's got to stay some distance away from this point and be evenly spaced. The minute we try to repeat this, let's use the tool. We'll select it and right click and use the Move Array Transformation. We can set the copies, and we want 3. And that's apply the equal constraint as well. So now if I click on, say, this point, it will array out from that point. But you can see if I drop the array, we don't have any distance constraints in here. So these are all mobile. which means we get lots of degrees of freedom. Let's highlight all those, except for this rectangle, and hit delete on the keyboard. This is where construction geometry comes to your rescue. Let's look at the anchor point first. Import the geometry and set an anchor point at this point. So if I place a dimension between this point and this point, it keeps that a certain distance away. But that's not going to repeat going this way. So instead, let's add another line and place a line in here, like so. Right click to cancel. Let's move this dimension over this way. We're concentrating on our construction geometry at the moment. So at this point on this one, set some dimensions. Go for length first of 0.25 and some height of the same, 0.25. Right click to cancel the tool and move this across. Let's add another line in. This one here. Place a line, connect up to this point, across to here. Right click to cancel, make these two equal. Select in both of those, using equal, and then select both of those again. And right click and toggle construction geometry, or select it from the toolbar. We've got this construction geometry now, and as you see, as we move this, both lines keep equal, which allows us to dimension this line here with a length constraint using the dimensioning tool. Let's set that to 2.5 millimeters. This is going to be a temporary constraint. What we can do now, if I right click and cancel the tool, is take the rectangle and place a rectangle symmetrical to this point here. Clicking those two and that point, and using the constraint symmetric. We're fully constrained now. It's time to add the array. To do that, let's zoom right in and make sure we highlight all the geometry. We can do that by looking at the start geometry here, clicking within some space above it, and highlighting all of that geometry, making sure we have everything within there. Now I can use the tool from the toolbar, the Move Array Transform, or we can right click and select the tool from the right click menu. On the left hand side, you see the translate parameters. Let's set the copies to 3. We only want one row, and we need to apply equal constraint. This will keep our constraints to a minimum. Now we need to come in and select the first point of the construction line. Click that once and then move across to the right. You can see what's happening. We're arraying out. So I need to come over to this point here and click again. We check what we have. We have the construction line going across here, and we have our rectangles. But there is a small problem. This point here isn't connected up with coincident constraint, so I can pull this down and you can see what's happening there. Control Z that. Let's highlight by clicking and dragging a box around that point. We should have 2 points show up as lines in here, so they're both selected, and then use the coincident constraint, and the same for this side. Coincident. Let's move across and take this one and make that coincident as well. So we have a fully constrained sketch now, but this one is too far this way. So we need to alter where this is going to sit. Remember back what we did with our construction geometry is that we set this 25 millimeters here between the start point and the end point of this construction geometry. If I double click this now and set this to reference geometry and hit OK, this becomes a reference geometry. And if we look at it, I can start dragging my geometry into place because this is allowed to change. And it updates as we drag this in. So I can decide where this is going to sit. And I may leave this as reference because I have these constraints here. So I could pull in this point here and constrain against it. Using the external geometry tool, create external geometry, and selecting this point. Right click to cancel. Let's take the 2 points. Use the dimensioning tool. And we'll bring this around to here and set this to 0.25. Same as the other side. We're fully constrained now. We can see our reference constraint here. Let's right click to cancel. I don't really need this anymore, so I can click on it and hit delete. And that's fully constrained. I can make amendments if I want, but let's close that now. We have the sketch. And if we select it, and we'll use the pocket. This will pocket all the way through. But we can see we've got these bits here. Now we can go for this if we wanted to, or we can change the direction and drop this down to custom direction. By altering the direction along the Y, so we're looking along this way, we can change that and we can alter the direction of that face. So I'm going to bring this out and do something like this. Let's OK that. Now we have the feature in place. We can mirror this over to the other side. Or we could add another sketch in here. Let's use a mirror. Take the last pocket, select it, and then use the mirror operation. Mirrored. It's going to ask us for a plane. At the moment, you can see the transformation has succeeded, but it's not in the right place. We want to mirror it over this plane here. The XZ plane. Come over to the plane and scroll down and find the XZ plane. That's mirrored across now. We can see that in there. And then hit OK. We've now completed the project for one side of the enclosure. We learned how to use the thickness tool and also combine multiple operations using additive lofts, pads, pockets, and also the taper option. We've also revisited the mirror. In our next lesson, we'll learn about multi-body modeling and also revisit this project to add additional features to it, such as the lid. With this area, we'll learn about substrate binders and multi-body Boolean operations. I hope you enjoyed that video. I hope to see you in the next lesson. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.